Good morning, everybody. Today we are going to wrap up Chapter 7. I know that seems weird. We went a little backwards, but I wanted to save the scientific notation to the end because you need to know how to multiply and divide exponents before you can really do scientific notation. So I didn't like the order of the book, so I changed this, and today we're going to do scientific notation. Now that we know how to how to multiply powers, divide powers, and raise powers to a power. Scientific notation is a way of writing very large, or very small numbers. That's all it is. When we're dealing with space travel or distances in space, or you're making maps, you're making a map and you want to have the correct scale from here to China, we're talking about large numbers, large values, and you're going to use scientific notation. When you're talking about the distance from here to Mars, and you want to plan how long it's going to take the vessel to get there, we're talking about large numbers. So instead of dealing with numbers that have 18 digits in them, we deal with scientific notation. Scientific notation uses powers of 10 in order to represent decimal movement. Whenever you move a decimal, you're really either multiplying by 10, guys, or dividing by 10, just so you know. For example, 3 times 10 equals 30. We all know that, but did you know why? Here's the decimal behind the 3, right? So I'm multiplying it by 110, so that means I move one place to the right. That's why it's 30, okay? So every time you multiply by 10s, you move the decimal to the right. Anytime you divide by 10s, you move the decimal to the left. So that's why they have this power of 10 in every scientific notation. Positive exponents are used for original numbers in absolute value that are greater than 1. Okay? Negative numbers, don't worry about negative numbers. Negative numbers are just as important as positive numbers, but when they're negative, it doesn't mean that you're going to have negative exponents. You look at the absolute value of the original number. If the absolute value of the original number is greater than 1, then you're going to use positive exponents. If the absolute value of the original number is less than 1, in other words, if it's decimals, okay, then you're going to use negative exponents. So again, if the value of the original number is larger than 1 in absolute value, it doesn't matter if it's positive or negative. If the absolute value of the original number is larger than 1, you're using positive exponents. If the absolute value of the original number is a decimal that is less than 1, then you're going to use negative numbers. Negative exponents, to be exact. So, how does it work? Converting from standard form to scientific notation. First thing you want to do, guys, is make the value of the given number a value between 1 and 10. It's not equal to 10, and it's not equal to 1. You want to make that value a value between 1 and 10. How do you do that? By moving the decimals either to the left or to the right. If you are moving the decimals to the right, that means that you are working with a decimal value. If you're working with a decimal value, that means that the absolute value is less than 1. So then you must use negative exponents. We have already said this before, but I'm repeating it now again. If you are moving to the left, that means that you are working with values that are larger than 1. And when you have original values that are larger than 1, you're going to use positive exponents. Okay? Now, words are a lot more difficult than actual math. Let's check it out. 22,300. First of all, is this a number in absolute value? Is this number larger than 1 or less than 1? So I'm going to use positive exponents, correct? Now, I want to make this number a value between 1 and 10. Where is the decimal of this number? Very good. It's right here at the end, just like money. Where do I move this to make it between 1 and 10, my brother? Yes.
You have to move it to the decimal spot where it's going to be between 1 and 10. So we're in between the 2 and the 2.
Okay, so you're going to go 1, 2, 3, 4 places to the left. 2.23 times 10 to the 4th power. Fantastic. Why was it positive again? Well, okay, it's positive because you move it to the left, but left and right can get confusing. Try to remember this, guys. Why did I use a positive exponent? Because the original number was larger than 1. Whenever you have a number that is larger than 1, you are adding exponents. Whenever you have a number, whether it's negative or positive, whenever you have an absolute value that is larger than 1, you are adding exponents. Whenever you have an absolute value that is less than 1, you are subtracting exponents. Let's look at this one. It's a negative number, but we don't care about that. Is the absolute value of that number larger than 1? So whenever we have an absolute value that is larger than 1, I'm going to use positive exponents. So here's my decimal. I'm going to go 1, 2, 3, 4, 5, 6 to the left. So I've got negative 1.25 times 10 to the 6th. A lot of people say, but Moro, you have a negative number. So what? What's the rule? If the absolute value is larger than 1, I am adding exponents. I use positive exponents. Are you with me so far? Now we'll do the decimal values in red. Is the absolute value of this less than 1?
Yes.
The decimal, right? So I'm going to use negative exponents. What would it be, my brother? You go 1, 2, 3 to the right. 2.3 times 10 to the negative 3. Why was it negative? Because the absolute value of the original number was less than 1. So whenever the absolute value of a number is larger than 1, I add exponents. Whenever the absolute value of a number is less than 1, if it's a decimal, I subtract exponents. Yes?
Would you ever put into a fraction or like 2.3 over 10 to the third so you can change it to a positive exponent?
Oh, God, no. He asked this. Can I put it like this? Technically, it's right, but no. That is not scientific notation. Please never do that. Thank you. Great question. Okay, D. Is the absolute value of that less than or greater than 1? So am I going to add exponents or subtract exponents? So I'm going to go 1, 2 to the left, 3.5 times 10 to the negative 2. Does that make sense, my brothers? Promise? Sir. Thank you. All right, now, second skill. Converting from scientific notation number to standard form. This one's even easier in my opinion. When a number is written in scientific notation, okay, has a positive exponent attached to the base of 10, simply move the decimal of the number shown to the right as many places as there are exponents. Fill in the gaps with zeros. When a number written in scientific notation has a negative exponent attached to the base of 10, simply move the decimal of the number shown to the left as many places as there are exponents. Fill in the gaps with zeros. Again, the words are nice and pretty, and that's all sweet, but what really works here is the math. So let's do the math. Yeah, these are a lot easier in my opinion. What I do here is, okay, first of all, I got 10 to the 5th, so am I going to move to the right or to the left? Okay, so I have 8.3, and you're going to go 1, 2, 3, 4, 5 to the right. I put an arrow so that I know that's where my decimal is, and then I fill in the baskets. And then I rewrite it nice and legible. 830,000. That's going to be my answer. If you give me this as the answer and you leave that like that, I will mark it wrong. Okay? No, you had to add 5 places. I went to the right 1, 2, 3, 4, 5. You fill in the baskets. Just because it went to the 5th power does not mean that there are 5 zeros. Thank you for asking. Great question. B, 4.2 times 10 to the negative 4th. Put the 4.2 here, and then which way am I going to go?
To the left.
Absolutely, my brother, to the left. You're going to go 1, 2, 3, 4. Put an arrow showing that that's where your decimal is. Fill in the baskets with zeros. Rewrite it nice and pretty. So that'd be 42 hundred thousandths. Remember, tenths, hundreds, thousands, 10 thousandths, 100 thousandths. 42 hundred thousandths. Does that make sense, boys? Awesome. Next, 3.75 times 10 to the 6 to the negative 6. So I write my 3.75 from my decimal. It's negative, so I'm going to go to the left. So I go 1, 2, 3, 4, 5, 6. Place my decimal where I ended my arrow. Fill in the baskets. Rewrite it nice and pretty. If you don't rewrite it nice and neat, guys, I will mark them wrong. I'm sorry, but I will mark it wrong. What do you mean? Do you have to put in the baskets? What do you? You don't have to draw the baskets. You're just going to do this without showing yourself where you're going. I do not suggest that. I do not suggest that at all. No. If you want to do it that way, sir, I cannot make you. But I do not suggest that at all. At all. I mean, I'm not trying to be rude, but I can do it. But I've done, I don't know, 5,000 of these, literally. So I know it already. But you guys are learning. I strongly suggest, please, that you follow my directions. 6.3 times 10 to the 3rd. So you have 6.5. Go 1, 2, 3 to the right. Put your arrow. Place your decimal. Fill in the baskets. Rewrite it nice and neatly. 6,500. Does that make sense, gentlemen? We promise. Okay? Now, let's put it all together. When you're multiplying or dividing numbers in scientific notation, this is what you guys had through the homework. So I said, don't worry about it yet. Don't worry about it yet. Today we can practice it, and you can definitely worry about it now. First step you want to do, multiply or divide the numerical values first. Just multiply the numbers first. Not the powers of 10, but just the numbers. Just multiply the numbers first. Secondly, multiply or divide the bases of 10. Remember to use the laws of exponents. If you're doing 10 to the 5th times 10 to the 3rd, well, you're multiplying the same base. You add the exponents. That's going to be 10 to the 8th. If you're doing 10 to the 5th divided by 10 to the 3rd, you're dividing exponents. You're going to subtract. So that's going to be 10 to the 5th. Okay? Remember your power rules. And then C, write the product of the quotient. This is the key. In proper scientific notation. What does that mean? Remember that the value, the numerical value, must lie between 1 and 10. So sometimes when you're doing this, not only do you have to multiply or divide, but then you got to convert at the end. Let me give you an example, please. Right here. 3 times 10 to the 3rd times 8 times 10 to the 6th. Step 1. What's step 1 here? What does it say for A? The numerical values only. So what's 3 times 8? So just put 24. Times, what's 10 to the 3rd times 10 to the 6th? 10 to the 9th. Now, is that in scientific notation? No, because the 24 is not between 1 and 10, is it? So what do I got to do?
Alright, so go where the decimal place at the end, you can move it over 1 to the left.
Okay, listen to what he said. Your decimal's here. You're going to go 1 to the left. Now, let's see if he gets this exponent correct.
Add 1 to the exponent,
Why did you add 1 to the exponent?
because now the number is less than.
No.
It was more than 10.
No, it was more than 1.
1. Not.
Good job, kid. Okay, let me explain that again to him, because we were talking and people at home may not have seen that. This is 24 times 10 to the 9th. My boy realized, hey, wait a second, this 24, that's not in scientific notation. Okay? So what do I have to do? I got to make it into scientific notation. Now, first of all, is this number, this absolute value, is it larger than 1? So am I going to add exponents or subtract exponents?
No, add.
Guys, is this absolute value larger than 1? So am I going to add exponents or subtract exponents? Going to add, guys. We just went over this. When the original number is larger than 1, you add exponents. When the original number's absolute value is less than 1, when it's a decimal, you subtract exponents. So you're going to go 1 to the left, and that's going to be 2.4 times 10 to the 10th power. Why? Because this original number was larger than 1, so you add exponents. Does that make sense? Guys, you're going to have a quiz on this. You're going to have homework on this. You're going to have a test on this. Does this make sense, my brothers? Yes? Okay. Let's say it was 240, good question, times 10 to, let's say, the 4th. Thank you, son. So I'm going to go 1, 2 to the left. So that's going to be 2.4 times 10 to the 6th. I added exponents because my original number, the absolute value of it, was larger than 1. Great job, son. Great job. Thank you. Does that make sense, gentlemen? Talk to me now, please, guys. This is what I'm here for. All right, let's move on then. 15 times 10 to the negative 6 divided by 3 times 10 to the 4th. Okay, so first things first, 0.3 into 15. Move the decimal 1 to the right, 1 to the right, bring it up. That's going to be 50. So I have 50. What's 10 to the negative 6 divided by 10 to the 4th? Remember, I got to bring it this time up here. No, no. Think about this. Look, guys. This is a positive, right? I got to bring it all to the numerator. So when I bring it up, am I not bringing it up as a 10 to the negative 4th? So it's going to be times 10 to the negative 10th. Done. Is that in scientific notation? Yes, because the 5... whoa, no. No. Whoa, wait. Pay attention, Mr. Morrow. You got 50, times 10 to the negative 10. Now, I've got to make this scientific notation, correct? Okay, so I'm going to move 1 to the left, right? Was this original number larger than 1? So am I going to add exponents or subtract? Okay, so it's going to be 5 times 10 to the negative 9th. Very good. Because negative 10 plus 1 is negative 9. Does that make sense, guys? Talk to me. Okay? Yes, sir? No, it's not supposed to be 11. Negative 10 plus 1 is negative 9, not 11. Now, I got 240 divided by negative 3. So let's do this first. There's going to be negative 80 times 10 to the, bring that 15 up. So it's going to come as a negative. So times 10 to the negative 7. Now, is this negative 80, is the absolute value of that larger than 1 or less than 1? Okay, is the absolute value of negative 80 larger than 1 or less than 1? Larger than 1. Very good. So, I'm going to move my decimal 1 to the left. Since it was larger than 1, am I going to add exponents or subtract? So it's going to be negative 8 times 10 to the negative 6. Excellent. Last but not least, 12 times 11 is 132. Times 10 to the negative 4th. Because 10 to the 4th times 10 to the negative 8, when the bases are the same, you add and keep the sign. Now, is this in proper scientific notation? No. So I'm going to move the decimal 1, 2 to the left. Give me 1.32 times 10 to the negative 2. Very good. Why negative 2? Because I moved it 2 places to the left. The original number was larger than 1, so I add exponents. Let me show you the other way when you have to subtract exponents. Let's say I have this, my friends. 0.032 times 10 to the 5th. In this case, is this original number less than 1 or larger than 1? So I'm going to go 1, 2 to the left, and that's going to be 3.2 times 10 to the third. Because when the original number is a decimal or less than 1, you subtract exponents. And gentlemen, that is it. Any questions, my brothers? Awesome. God bless you. Have a great day.